All right, getting towards the end of this one, question 9, and the tables have turned. So no longer are these people working together to try to move productively and get the sled to somewhere. They are now fighting over the sled. And so if we stop and think about what this means, um, those forces aren't going to add together anymore, right? They're fighting against each other. They're going to be going in opposite directions, and so those forces are going to work against each other. That's something we'll want to keep in mind for this. In the context of the question, we're looking for acceleration. So think about the formula we learned in the last question. Acceleration can come from net force, which is good to resolve these extra forces, divided by mass. Like the last one, we have one of these numbers now. We know the mass because of the units of kilograms. We know that the mass is right here. What we don't know is what's the leftover force, right? We know the pieces, we know what each person's doing, but we don't know how they're affecting each other yet. And that's the important part. So we'll dig a little deeper, see if we can figure out something about net force, and then use that to move on. Okay? So net force, if they're fighting over something, I hope it makes sense that these two numbers are going to work against each other. They're going to subtract. And this question was designed that the larger one should always be first so it stays positive, but technically they can also help you get an idea of direction depending on the context. All right, so here, 305.49 newtons minus 207.99. So part of that force is canceled, and we're left with just basically a third of it. The difference here is, looks like 97.50, just to keep the two decimal places like we had. Now that I know how much force is left over from the two people fighting and partially canceling each other's work, I can plug that back and finally resolve the question. So the net force was that leftover 97.5. The mass from the original question, we're told 22.86 kilograms. Remember the units. The newtons are a combination of kilograms and meters per second. So the kilograms cancel, meters per second squared. We get meters per second squared left over here. Then dividing these, we get a little more than 4 1/4. And there we go.